The digital space is a world of connection and opportunity. But take this moment, for example.
The web has made it possible for you to enroll in this program, where you'll learn from the personal stories of developers at Meta.
By the time you have completed this professional certificate, you can become a creator of digital experiences. Connection is evolving, and so are you.
You might not have a background in tech at all, and that's okay. Even if you have no experience, this program can get you job ready within a single year.
So how can this professional certificate prepare you for a job at an organization like Meta?
The Database Engineer Professional Certificate will help you build job-ready skills for a database engineering role while earning a credential from Meta.
From Meta engineers, you will learn about how they collaborate to create and test high-performance databases.
You'll also discuss interesting topics with other aspiring database engineers.
And complete a range of coding exercises to improve your skills.
It's important to complete all the courses in this certificate in order, as each course will build on your skills.
Although we have a recommended schedule for each course, the program is entirely self-paced, which means your time is your own to manage.
As you make your way through the courses in this certificate,
You'll learn how to model and structure a database according to best practice and create, manage and manipulate data using SQL, one of the most widely used languages for working with databases.
You'll also learn how to use the Django web framework to connect the front end of a web application to your database.
For your final project, you will create a functional relational database designed and developed with best practice architecture
To showcase as part of your portfolio during your job search.
you'll also be ready to collaborate with other developers, as you will have learned to use Git and GitHub for version control.
In the final course, you will prepare for the coding interview. You'll practice your interview skills, refine your resume, and tackle some common coding challenges that typically form part of technical job interviews.
Once you complete the program, you'll get access to the Meta Career Program's job board.
a job search platform that connects you with over 200 employers who've committed to sourcing talent through Meta's certificate programs.
Who knows where you will end up? Whatever the future of connection looks like, you'll be part of its creation. Let's get started.
Welcome to the next course in database engineering. The focus of this course is on database structures and management with MySQL. Let's take a moment to review some of the new skills that you'll gain in these modules. In the first module of this course, you'll learn how to filter data using logical operators, perform joins on tables and make use of aliases, group data using the group by and having clauses, and deploy the any and all operators in a database. In the second module, you'll explore key concepts around the topics of updating databases and working with views. For example, you'll learn how to insert and update data using the MySQL replace statement, make use of constraints in a MySQL database, and change the structure of tables using alter and copy table statements. You'll also learn how to use subqueries and how to combine them with comparison operators, and you'll discover how to create virtual tables with a MySQL create view statement. In Module 3, you'll explore functions and MySQL stored procedures. By the end of this module, you should know how to make use of common MySQL functions like numeric, string, and date functions, deploy comparison and control flow functions, and work with stored procedures. During these modules, you'll encounter activities to test your knowledge and skills. You'll receive the opportunity to demonstrate some of this learning along with your practical database skill set in the lab project. And you'll also demonstrate your knowledge of these topics in a graded assessment. So, what are you waiting for? Let's get started.
You know what's amazing is databases are present in our everyday interactions with these amazing digital experiences we have. So whether it's looking up somebody's phone number on your smartphone, or whether you're looking for your next movie to stream, or paying for your groceries at the checkout counter and scanning your groceries, you're interacting with databases every step along the way. My name is Daniel Bloomfield Ramajan. I'm a software engineer working out of our Meta DC office. And I've worked in security, in community integrity, and currently in the privacy space. As your use of data for an application grows, you increasingly need to be able to find that information quickly, need to manage, delete it, update that information quickly. And so without a database management system, you're either left to kind of create those structures on your own, and you may be successful at first, but as the scale of what you're trying to do grows, it becomes increasingly harder. So these database management systems, something like MySQL, gives you that almost for free. You have all of that service and functionality already available to you, which frees you up to then focus on, let's say, the business problems that you're trying to solve, like the user problems you're trying to solve, without having to necessarily worry about everything that's powering the data management layer. MySQL it's a relational database management system. So it allows you to store data, retrieve that data, and manage it, delete and update it for a variety of uses. So it can be applied to many different application types. So everything from the motor vehicle administration, managing my driving records, to something like the likes and shares I get on my Facebook app. All of that can be managed in a database, and MySQL is one of the most popular databases we have in the world. So MySQL allows you to automate a lot of things like making backups and setting up failovers, updating schemas. It allows you to handle very high concurrency requests. So if you've got web applications or needs where there's a lot of requests coming in, it's particularly good at that. It also has this fantastic community, which means you have forums where you can reach out for help. You've got great people that can provide you support, documentation, and it's open source, which means you can always take a look at the code and you can actually make requests to the creators and contributors to that software. We at Meta use MySQL to store and retrieve the social graph, the interactions, the shares, the likes. And so I know that when my friends used the Facebook app and saw my picture last week, that I can visualize the thousands of requests being made across our fleet of MySQL servers to retrieve that information and display it to them and to me. So MySQL is powering all these amazing digital experiences for us. We use MySQL because it provides automation, and that means a small group of engineers can manage a very large fleet of servers and can do things like these backups and failovers and can automate all those functions. And it's also very good for these high transactional requests. So a lot of what we do at Meta are these short bursts of very precise requests for insertion of data, deletion of data, lookup of data, and MySQL excels at that. It's incredibly rewarding to learn about databases, and it can be challenging not only to code, but to learn database management and configuration, data structures. But the rewards are that you are empowered to build incredible experiences, incredible solutions to real user problems, or you can build applications that will serve, for entertainment. There's a variety of uses for software that are all going to be powered by well-organized, structured data. So hang in there, go through this lesson, learn, because you will be standing on the shoulders of giants with all this data layer that will be readily available for you, and you will propel you to take it to the next level. I hope you will have learned that data is at the heart of every application, and that structuring that data and managing the data effectively such that you can retrieve the data quickly, you can process it effectively, and you can display the right information to the user is super important. And the knowledge you have of database management will help you not only structure that data, but you will influence everything else that comes after it, the processing, the APIs, and even something like the user interface. So you have a huge opportunity to influence software development projects all the way from the back end to the front end experience by your database management skills and data skills. I hope that you get a chance to apply this knowledge to a future role, and I wish you the best in your next endeavor.
You might already be familiar with using a where clause and a condition to filter data in a database table. But what if you need to specify multiple conditions in a where clause? You can use logical operators to specify multiple conditions or rules. So when the data is filtered, all specified conditions are applied. By the end of this video, you'll be able to identify the logical and or operators and explain how they're used to combine conditions, and develop a working familiarity with the logical not operator and outline how it is used with data filtering. Before you explore how to filter data using multiple conditions, let's take a moment to recap how the where clause works. It's important that you understand it before working with logical operators. When filtering data in a database table, you can add a where clause to your SQL select statement to specify a condition or rule for how the data should be filtered. A select statement begins with the select keyword or command. You must then specify the data or columns to be queried. You then add the from keyword, followed by the table you need to query. Finally, you must add a where clause and a condition. But as you've just learned, it's also possible to specify multiple conditions in the where clause. These conditions are specified using logical operators. Let's begin by exploring the and or operators. The and operator is used with the where clause to filter data. It checks if all combined conditions meet the value of true. And the or operator checks if any of the combined conditions meet the value of true. Let's take a moment to explore the syntax for each of these logical operators. Write the select statement as usual. However, in this instance, multiple conditions are placed after the where clause and combined using the and operator. The statement checks if all these conditions yield a value of true for a record. If so, then that record is included in the results set. With the OR operator, a record is included in the results set if any of the conditions separated by OR is true. That is, if at least one condition yields a true value for a record in the table, then that record is included in the query results set. Next, let's look at the NOT logical operator. The NOT operator works slightly differently to other operators. It selects a result to be included in the query results set only if the conditions specified in the where clause are not true. In other words, it reverses or negates the results that are returned once the condition is evaluated. To use the NOT operator, you just type NOT after the where clause, followed by the required condition. Let's take a few minutes to find out how these operators are used over at Lucky Shrub. Lucky Shrub are reviewing their accounts and need to generate specific details on their customers and the purchases they've made. They can complete this task by filtering data with the use of logical operators. In Lucky Shrub's database is a table called Customer Purchases. This table contains the data Lucky Shrub needs to complete their queries. The data is divided into the following 4 columns: Customer ID, Customer Names, Customer Locations, and Purchases. The value of each customer's individual purchase. Lucky Shrub first need to identify customers from the location Gila County who have made purchases of over $2,000. This requires 2 search conditions. The first is customers who are from Gila County, and the second is customers who have made purchases of over $2,000. You can retrieve these details by writing a basic select statement as follows. Begin with select all from the table customer_purchases. Next, type the where clause, then the first condition as follows. Purchases column, the greater than operator, and the figure of 2,000. Then type the AND operator to include a second condition. This second condition targets the location column and uses an equal operator to return all results for Gila County. The AND operator here combines the 2 conditions. It ensures that both conditions are evaluated when filtering data from the table. So, your select statement is instructing SQL to select all records from the Customer Purchases table that satisfy the following criteria. Purchases greater than $2,000 and made by customers in the location of Gila County. For a record to be included in the result set, its purchases column must have a value greater than 2,000. If so, then the first condition yields a true value. In addition, the location column must have a value of Gila County. If this is the case, then the second condition also yields a value of true. And as you just learned, the AND operator here insists that the results of both conditions are combined. This is another instance which yields a value of true. So any records that match are included in the result. Any records in the table that do not yield the value of true for both conditions are omitted from the results. Your query is now ready to run. So press Enter to execute. The results set that this query returns contains 2 records. There are 2 customers from Gila County who've made purchases over $2,000, Benjamin Claus and Julie Marr. Now Lucky Shrub need to identify customers who are from Gila County or Santa Cruz County. The logical operator OR can be used to combine multiple conditions in the where clause, so it's perfectly suited to this task. For this query, you first need to generate a list of customers who are from either Gila County or Santa Cruz County. So the first step is to write the following select statement. Select all from customer purchases and then add the where clause. This where clause is then followed by the first condition, location equal to Gila County. Then insert the OR operator followed by the second condition, location equal to Santa Cruz County. You now have a where clause that uses the OR operator to combine the two conditions. For a record to be included in the result set, its location column must have a value of Gila County. If so, then it meets the first condition and yields a true value. Or the location column must have a value of Santa Cruz County. If this is the case, then the second condition yields a true value. The OR operator ensures that at least one of these conditions will yield a true value. Any matching records will be included in the result. A record in the table that does not yield a true value for either condition is omitted from the result. Press Enter to execute the query. In this case, the result returns 3 records or customers. Next, Lucky Shrub need to retrieve the details of customers who do not reside in Gila County or Santa Cruz County. They can perform this task using the NOT logical operator. It's used in a similar way in the where clause of a select statement. You can write the statement as before, but this time type a NOT operator after the where clause. Then list the conditions, location equal to Gila County or location equal to Santa Cruz County. In this query, the conditions have been enclosed in parentheses because there are multiple conditions. Parentheses are not required where you have just one condition. The NOT operator checks the records for values that do not yield a true value for the given conditions. In other words, records that do not yield a value of true for either of the listed locations. Press Enter to execute the query and generate the output. So, all the records that have a location value which is not Gila County or Santa Cruz County are included in the result. The remaining records are omitted. The output shows 4 records from the customer purchases table. If you find all these examples and operators a bit complicated, don't worry. You'll review detailed examples of how to use these operators in later videos in this course. For now, you should just be able to identify each of the operators and explain their syntax. You might already be familiar with filtering data using the AND and OR operators. But what if you need to perform more complex data filtering tasks, like filtering data based on a pattern? You can use more logical operators such as in, between, and like. By the end of this video, you'll be able to identify the in, between, and like logical operators and explain how they're used, and explain how wildcard characters can be used with logical operators to filter data. Let's begin with a review of the in, between, and like operators. The in operator lets you specify multiple values in the where clause. The between operator selects values within a given range. These values can be numbers, text, or dates. And the like operator is used to filter data based on pattern matching. Let's look at the syntax for the in operator. The in operator requires slightly different syntax than a typical select filter statement. After the where clause, you must type the column name to which the in operator is applied. You then need to add the in operator, and you must also include the set of values within parentheses. If the specified column's value of a record matches with any value in the set, then that record will be included in the query result set of the select statement. The in operator is like a shorthand for multiple OR conditions. You also can use not in to filter the opposite results of those you receive from the in operator. Next, let's review the between operator. For the between operator, you must also specify the column name after the where clause. The between operator is then applied along with the 2 required values. These 2 values mark the boundary of a range. In other words, they're the beginning and ending values of the range. The operator then selects values within this given range. The values that can be used with the between operator include numbers, text, and dates. If the specified column's value of a record falls within the value range specified here, that record will be included in the query result set of the select statement. Finally, let's look at the like operator. The like operator is used to filter data based on pattern matching. The operator is placed after the where clause and specified column name. A pattern to be matched against the column data is then added. This pattern can be written using what are referred to as wildcard characters. The first of these is the % sign, which represents 0, 1 or multiple characters. The second is the underscore sign, which represents one single character. For example, a pattern could be written as G __ %sign within a pair of single quotes. As you've just discovered, each underscore represents one single character, while the % sign is 0, 1 or more characters. So this pattern searches for values that start with the letter G and are at least 3 characters in length. If the specified column's value of a record matches the given pattern, that record will be included in the query result set of the select statement. Let's look at a demonstration of these operators in the Lucky Shrub database. Lucky Shrub are performing a review of their accounts. They need to generate specific details on their customers and the purchases they've made. They can complete this task by filtering data with the use of the in, between, and like logical operators. In Lucky Shrub's database is a table called Customer Purchases. This table contains the data Lucky Shrub need to complete their queries. The data is divided into the following 4 columns: Customer ID, Customer Names, Customer Locations, and Purchases, the value of each customer's individual purchase. First, Lucky Shrub need to use the MySQL in operator in the where clause to identify customers from the location Gila County who've made purchases of over $2,000. You might already be familiar with filtering data using the OR operator. The in operator is like a form of shorthand for multiple OR conditions. You can get the same result as the OR example by using the in operator. To extract the required data using the in operator, write a basic select statement as follows. Begin with select all data from the table Customer Purchases. Next, type the where clause, then the first condition as follows. Purchases column, the in operator, and the figure of 2,000. Then, within parentheses, specify the set of values separated by a comma, Gila County and Santa Cruz County. When run, this query returns 3 records or customers. These are the same results as the OR operator returns. Now let's check out how the MySQL between operator functions in the where clause. In this example, Lucky Shrub need the details of customers whose purchases are in the range of $1,000 and $2,000. Write the select statement as before. Then add the where clause. The where clause is followed by the filter column, which is purchases. Then add the between operator and give the value range. The range begins with the value 1,000 followed by and, then ends with the value 2,000. The between operator filters out the records that have a purchase value between $1,000 and $2,000, including the beginning and end values. In this case, the between operator is a quicker and easier way to filter out the records that have a purchases value greater than or equal to $1,000 and less than or equal to $2,000. Finally, let's see how Lucky Shrub make use of the MySQL like operator. The like operator is used for pattern matching. When used in a where clause, it searches a column for the given pattern. This means that it filters out data from the table based on the pattern. It's often used in conjunction with wildcards for single or multiple characters. Let's demonstrate an example using the pattern on the location column. You can filter out the records that have a location value that matches the pattern. Lucky Shrub's pattern must be set to find any values that start with G and are at least 3 characters in length. First, write the select statement just as you've done before. Then add the where clause followed by the name of the filter column, location. Finally, add the like operator followed by the pattern, which in this example is G, followed by 2 underscore characters and a percentage symbol. Press enter to execute the query. The output that's generated contains 3 values that start with G and are at least 3 characters in length. Any values that don't match the pattern have been omitted from the table. Lucky Shrub have completed their data filtering tasks and returned all the required results from their database. You should now be able to combine conditions and filter data using the in, between, and like logical operators. Great work. Little Lemon Restaurants has run into some problems with their database. Some of the table and column names in the database are too long, which is causing issues with the output of queries. They need to find a way to generate results that are simpler to use, read, and understand. Fortunately, they can solve these issues with MySQL aliases. Over the next few minutes, you'll discover how Little Lemon can make use of MySQL aliases, and by the end of this video, you'll be able to demonstrate an understanding of the concept of an alias in a database, identify examples of situations in which it is beneficial to use aliases, and demonstrate the use of alias in MySQL queries. But first, you might be wondering, what is an alias in the context of SQL? SQL aliases are used to provide database columns and tables with temporary names. These temporary names make it simpler to use, read, and understand the output of the database. For example, Little Lemon can use aliases to shorten the names of tables and columns in their database. There are 3 common situations in which it's useful to consider an alias. An alias can be used to rename a table or column whose original name is too long or technical. It can be used with a concatenation function to combine an output into one column instead of 2. And you can also use an alias to create distinct table names when dealing with multiple tables. However, it's important to bear in mind that the syntax for creating and using an alias can change depending on which of these issues you're attempting to resolve. Let's take a few minutes to review an example of the syntax for each scenario, beginning with renaming tables. To rename a table, you need to use a select statement which begins with the select keyword. Then type the original column name followed by the alias. Both must be separated by the as keyword. The as keyword creates the alias. You can also include other columns in the table, with each separated by a comma. Then write the from keyword followed by the table name. If your table requires multiple aliases, then write out each column name and use the as keyword for each column you need to create an alias for. For example, in their client orders table, Little Lemon can use an alias to rename lengthy columns like client order information to just orders. Next, let's review the syntax for a concatenation function that combines an output into one column instead of 2. The select command is used to retrieve data. This is followed by the concat function, which concatenates or combines the information extracted from the column names placed in parentheses. These names must be separated by commas and a pair of double quotation marks. The quotation marks split the output by creating an empty space between the concatenated values. The as keyword is then added, followed by the name or alias you want to assign to the new concatenated column. And the from keyword specifies the table SQL must extract the data from. Little Lemon can use a concatenation function to combine the values contained in the first and last name columns of their client details table. These values are then placed in a new concatenated column called client names. Finally, let's explore the syntax for querying multiple tables. The first thing to note when querying multiple tables is that you can use a one-character alias to represent each table. For example, if you're querying 2 different tables, then you can use X for table 1 and Y for table 2. So the syntax then begins with a select command followed by the tables and columns to be queried. You can query columns using dot notation, such as x.column1 to query table 1 column 1 or y.column2 for table 2 column 2. Next, add the from keyword. Then type the original name of each table alongside its alias, with both separated by the as keyword. Finally, add a where clause and conditions as required. For example, perhaps you're querying prices in an online store database and want to return a list of items that are less than $12 for table 1 and $5 for table 2. Those are the 3 main instances in which MySQL alias can be used along with their related syntax. Now that you're familiar with the concept of MySQL alias, let's see if you can help Little Lemon with their databases. Little Lemon Restaurant has a table in their database called Food Orders Delivery Status that keeps track of food orders. The table has 2 columns called Date Food Order Placed with Supplier and Date Food Order Received from Supplier. However, these column names are too long and complex, so they need to be simplified to make the database more efficient. You can use aliases to simplify the output so that the column names are easier to read and understand when queried. Begin with a select statement and target the order ID column. Then rename the Date Food Order Placed with Supplier column as Date Order Placed. and rename the date food order received from supplier column as date order received. Notice that there are double quotation marks used for order date received because the alias name contains a space. In other instances, you can declare the alias without the use of quotation marks. Finally, type a from keyword followed by the name of the table. Then click Enter to execute the query. The output now shows the alias names instead of the original column names, which makes it much easier for Little Lemon to track food orders. However, you can make this table even more efficient. For instance, you could concatenate order ID and order status into one column instead of two. As you learned earlier, you can use a SQL alias with functions. Write the statement as follows. Begin with a select command and then the concat function. Then place the columns you want to concatenate in a pair of parentheses. You should also make sure that you include quotation marks to split the output. Next, use the as keyword to create the alias. In this instance, you can call the alias column order status. Then use the from keyword to identify the table. Finally, hit Enter to execute the query. The output shows the new order status column with the concatenated info. Finally, let's review how to work with multiple tables in the database. The restaurant has divided their menu into two tables called starters and main courses. Both tables show the names of the meals available to order and their respective costs. As part of a new promotional campaign, Little Lemon want to promote starters that cost $7 or less and main courses that cost $15 or less. So, you need to query these tables and identify the meals that match these prices. In this instance, you can use a one-character alias of S to represent starters, and you can use C to represent main courses. Add these aliases into a select statement and use dot notation to request the name and cost of the meals. Then use the from keyword to identify the tables and the as keyword to create aliases for each one. Courses is C and starters are S. Finally, add a where clause and specify the condition. The condition returns all starters less than $7 and all main courses less than $15. Finally, press Enter to execute the query. SQL generates an output that shows all related costs in one table. All issues with Little Lemon's database have now been solved using MySQL aliases. Thanks to your assistance, Little Lemon's database is now more efficient to use, and they've identified some great meals to include in their next promotional campaign. With the skills you've gained from these tasks, you should now be able to demonstrate an understanding of the concept of an alias in a database, identify examples of situations in which it is beneficial to use aliases, and demonstrate the use of alias in MySQL queries. Great work! Lucky Shrub Gardening Centre need to gather information on their customers and the orders they've placed, but the records are held in 3 different tables. However, they can extract this information from their database using joins clause to join the required elements of these tables together. Over the next few minutes, you'll discover how the joins clause works, and by the end of this video, you'll be able to demonstrate an understanding of the join concept in a database and describe the main types of joins in MySQL. Let's take a closer look at the problem that Lucky Shrub has encountered with their database tables. Lucky Shrub needs to determine what products were ordered and which customers placed the orders. However, this information exists in 3 separate entities or tables: customers, orders, and products. So, how can Lucky Shrub extract records from 3 different tables? Before you can begin to assist Lucky Shrub, you first need to understand the concept of joins. The SQL join clause is used to query data based on a common column between 2 target tables. For example, the customers and orders tables both contain a customer ID column, and the product ID column is a common column between the orders and products tables. These common columns can be used to join these tables together and extract the required records. There are 4 types of join used to combine tables: an inner join, which extracts or selects records of data that have matching values in both tables, and a left join that extracts or selects records of data from the left table and all matching records from the right table. The right join, which extracts or selects records of data from the right table and matching records from the left table, and the self join, in which a table is joined with itself to retrieve info that exists in the same table. Let's begin with a review of the inner join. An inner join returns records of data that have matching values or columns in both the left and the right tables. This relationship between the two tables can be conceptualized in the format of a Venn diagram, as can all other joins. In terms of syntax, the left and right tables are identified as Table 1 and Table 2 respectively. Lucky Shrub need to identify the full names of all clients that placed orders with the business. To complete this query, they need the clients table and the orders table. They can then create an inner join using the client ID column that exists in both tables. The output result reveals the records of all clients who placed orders, and the client ID represents all records with matching IDs to be listed. The syntax of an inner join begins with a select statement which queries the left table and the column with the matching values. The from keyword is then added, along with the name of the left table. Next is the inner join clause, followed by the name of the right table. Finally, the on keyword is used to identify the inner join that the tables share. Next, let's move on to review the left join. The left join returns all common records in a similar way to the inner join. In addition, it returns all available records of the common column from the left table, even if there isn't a match in the right table. Lucky Shrub can use the left join table to extract data from the clients and orders tables using the client ID values. The join locates 4 matching records between the two tables and places them in the common area of the Venn diagram. The left join syntax begins with a select statement in which the required columns from Table 1 are identified. The as keyword is then used to create an alias for each column. The from keyword is used to identify the left table, which is the one that must be queried. And once again, the as keyword is used to create an alias for this table. The left join clause is then used to join Table 2 and assign an alias. Finally, the on keyword equates the matching columns between the two tables. Now let's review an example of the right join. The right join returns all records from the right and left tables, but with the right table as the main target table. For example, Lucky Shrub can use the right join to extract records of data from the orders and products table based on the product ID values. This lists all products from the products table joined with the matching related orders details in the left table. The right join syntax is very similar to the left join. The only difference is that the right join clause is used to extract records of data. Finally, there's the self join. A self join is a special case in which a table must be joined with itself. In other words, one table is treated as two in order to extract specific information from either the left, right, or inner join. In the case of Lucky Shrub, the business holds records of all staff members in a staff table. The table contains records on sales floor employees and line managers. Lucky Shrub can treat the table as two tables to determine who is a line manager and who is a sales floor employee. A self-join syntax is written as a select statement in which an alias is created for the common column in Table 2. You've encountered a lot of information in this video, particularly in terms of syntax. Don't worry if it doesn't all make sense at this stage. In the videos that follow, you'll learn how to create each type of join in more detail. But for now, you should be able to demonstrate an understanding of the join concept in a database and describe the main types of joins in MySQL. Well done. Lucky Shrub Gardening Centre require information on orders recently made by their clients. This information is stored in 2 separate tables, the clients table and the orders table. But there must be a more efficient way to review this information that doesn't involve using 2 tables at the same time, right? Thankfully, Lucky Shrub can use the inner join clause to return records of data based on a common column with matching values in both tables. In this video, you'll help Lucky Shrub to complete this task. And by the end of this video, you'll be able to apply the inner join concept in MySQL and use SQL aliases to create temporary column names. As you're probably aware by now, databases normally have more than one table. In fact, database normalization rules dictate that related data should be held in separate tables. So let's begin with a quick review of the 2 tables. The clients table has 4 columns: client ID, full name, contact number, and address. And the orders table has 5 columns: order ID, client ID, product ID, quantity, and cost. The first task is to identify the full names of all clients who made orders. You can do this using the inner join clause in a SQL select statement. The statement begins with the select command. This is then followed by the column full name attached to the client's table, separated by a dot. This queries data from the full name column of the client's table. Then the from keyword is used to target the client's table. Next, the inner join clause creates a new row of data for each matching record. In other words, where the client ID in the client table matches the client ID in the orders table. And the equal operator ensures the matching condition must be met. Remember that it's important to specify the table name of each column when you are dealing with multiple tables in the same statement. This is especially important when the column name is used in more than one of the queried tables. For example, client ID exists in both the clients and the order tables. Press Enter to execute the query. The output results set lists the full names for all clients that have made orders. This example just extracts a list of names, but you can also query other information from both tables. For example, you can display the column names with more user-friendly labels if required. For instance, you can take the client ID, full name, and contact number columns from the client's table and create a join with the product ID, quantity, and total cost column from the orders table. You can do this with the following SQL statement. Start with a select command that selects the required columns from the client's table. Then use the as keyword after each column to create an alias. In other words, create a new name for each column. Then do the same for the required columns on the orders table. So, in this statement, each column is attached to the related table name. And the alias technique is used to create new names for each column. Click Enter to execute the query. The result set is a table with all required data related to the 4 matching clients' IDs, CL1, CL2, CL3, and CL4 as shown in the output table. In this video, you explored how to work with the inner join clause in MySQL to query data from 2 tables in the database. Also, you learned how to use an alias to create temporary column names that have more readable labels. Lucky Shrub can now review the data they need using a more efficient table thanks to the inner join clause. And you should now be able to apply the inner join concept in MySQL and use SQL aliases to create temporary column names. Great work. Lucky Shrub need to review data on orders made by their clients. This data exists in 2 separate tables, clients and orders. Lucky Shrub can query data from both tables using the left and right join clauses in MySQL. These clauses will work because both tables share several closely connected columns. In this video, you'll help Lucky Shrub use the left and the right join clauses. And by the end of this video, you'll be able to demonstrate how to apply a left join and a right join in MySQL and utilize aliases to create temporary columns and table names. Let's quickly review the 2 tables before creating the query. The clients table contains 4 columns: customer ID, full name, contact number, and address. And the orders table contains 5 columns: order ID, client ID, product ID, quantity, and cost. The first step is to create a query for the client ID and client name columns within the client's table, which is the left table. Then you must create a join with the following columns from the order table, the right table: order ID, quantity, and cost. You can use the left join clause in the SQL statement to complete this task. To start, use the select command to retrieve data, followed by the column client ID and full name attached to the client's table, separated by a dot. This syntax retrieves data from the 2 columns from the client's table. This data then joins the order ID, quantity, and cost columns from the orders table. As you're probably already aware, it's important to specify the table name of each column when dealing with multiple tables in the same statement. This is especially important when the column name is used in more than one of the queried tables. For example, the client ID column exists in both the clients and orders tables. You can also use the SQL as keyword to create suitable aliases for the column names when displayed in the output result set. And you can use the as keyword to create aliases for the 2 tables as follows: C for clients and O for orders. This now means that instead of repeatedly typing clients to specify the column source table, you can just use C. And instead of using the word orders, you can write O. In this statement, the left join clause creates a new row of data for each matching record from the left table, the clients table. It does this even if there are no matching records in the orders table, which is the right table. For example, the clients with IDs CL5 and CL6 have yet to place any orders. This means that null values will be inserted for related columns from the right table. Finally, press Enter to execute the query. The output result table contains several null values for the clients with IDs of CL5 and CL6. This is because they have not yet made any orders. Next, let's create a similar query using the right join concept. You can use similar syntax to the previous query. Just replace the left keyword with the right keyword. In this statement, clients represents the left table and the orders represents the right table. The right join clause extracts data from both tables based on the client ID values, just like the previous example. Executing this query should return all requested information from the orders table, right table, joined by the requested information from the clients table, left table, based on the common column, client ID. So, press Enter to run the query and create the output. The output shows that the right join has returned all records from the right, or orders table, where a client has made an order. And it extracted the matching records from the left, or clients table, based on the client ID values. No null values were printed in the output result table. This is because all clients who made orders already exist in the clients table. Lucky Shrub now have the order and client information they need. And you should now be able to demonstrate how to apply a left join and a right join in MySQL, and utilize aliases to create temporary columns and table names. Good work! The Lucky Shrub database has a table called Employees, which lists all staff in the business. Some of these staff members are line managers, and other employees report to these line managers. Lucky Shrub needs to query the data from this table to determine which roles everyone is assigned. They can complete this task using the self-join clause, a special join case. This clause lets Lucky Shrub create a join between rows on the same table so that they can extract specific information. But the table must be treated as two tables to perform the required joins. Over the next few minutes, you'll help Lucky Shrub with this query. And by the end of this video, you'll be able to apply the self-join concept in MySQL and use an alias to provide same table with two different names. Let's begin by reviewing the employee table from the Lucky Shrub database. This is the table that stores the required information on employees and their line managers. The table includes 5 columns: employee ID, full name, job title, county, and line manager ID. In this table, the primary key employee ID values are also used in the line manager ID column to show who manages each employee in the Lucky Shrub firm. So, your main task is to list the full name of all line managers and the employees they manage. The full names of both sets of employees exist within the full name column. To complete this task, you can create the employees table as 2 identical tables. Then create an inner join to investigate each employee ID and match it with the line manager ID. Then extract the full name value and print it as either line manager or employee. And remember that the line managers are also employees. Before writing the query, remember that the self-join clause creates 2 tables from 1. In other words, know you're dealing with 2 tables in your query, not just 1. So let's begin with a SQL select statement. The statement uses E1 with an as keyword to declare an alias for the first employee table. And it also uses E2 with an as keyword to declare an alias for the second employee table. Remember that the employee table is the same in both cases. In addition, your statement queries the full name column from the E1 table, and it uses the as keyword to declare a suitable alias name of line manager from the left table. It then queries the full name column from the E2 table and uses the as keyword to declare an alias of employee from the right table. Name columns from both employee tables, but only once there's a match between the column values. In this instance, the condition is E1.employeeID equal to E2.linemanagerID. In other words, the condition matches the employee ID with the line manager ID. If it finds a value of true, then the full name is returned from the left table and displayed in the line manager column. And the full name is also returned and displayed as an employee from the right table. Press Enter to execute the query. The output results set links the line managers with the employees they manage. A quick summary of the output results set shows that the employees, Seamus and Greta, report to the line manager Simon. Simon reports to himself, and all other staff report to Seamus. Thanks to the self-join clause, Lucky Shrub have now determined which employee is in which role, and you should now be able to apply the self-join concept in MySQL and use alias to provide the same table with two different names. Good work. Lucky Shrub are filing their end-of-year tax returns and must provide information on all employees that they have hired over the last 12 months. There are several full-time employees in the business, and there are several part-time employees who were recently hired to help with the holiday season. But the records for the full-time and part-time employees are stored in separate tables. So how can Lucky Shrub combine these records into one table? They can use the MySQL union operator. Over the next few minutes, you'll discover how the union operator works, and by the end of this video, you'll be able to demonstrate an understanding of the union operator and explain how the union operator is used in MySQL. Let's begin with a definition of the union operator. The union operator is used to combine result sets from multiple statements in the same query. For example, you can use the union operator to join two select statements in order to combine their result sets and present as one table. So how does the union operator work? Let's look at the syntax and find out. You begin with a select statement, followed by the names of the columns that must be queried. The from keyword is then used to target the table in which the records are located. Next, you add a union operator, followed by a select statement that queries the required records from the second table. The union operator essentially creates a union between the two select statements. There are a few best practices that must be observed when creating SQL select statements with a union operator. Every select statement must have the same number of columns. All related columns have similar data types, and all related columns must have the same order in every select statement. But what about cases where the same value exists in both tables but appears only once in the combined set of results, like a name or a location? This happens because the union operator only returns distinct values from the targeted tables. To list all values, including duplicated data, you can use the all keyword. The use of the all keyword after the union operator ensures that all values remain, even duplicated ones. Let's explore a working example of the union operator. As you saw earlier, Lucky Shrub need to gather information on all employees that they have hired over the last 12 months. But the data for their full-time and part-time employees is stored in separate tables. Let's help them out. Lucky Shrub need to combine the records from two tables into one using the MySQL union operator. Both the full-time employees and part-time employees tables include the same four columns: employee ID, full name, contact number, and location. Lucky Shrub need to query the full names and addresses or locations of all employees. To combine the results from both tables, you can write two select statements that target the full name and location columns. One statement targets the full-time employees table, the other targets the part-time employees table, and a union operator is placed in between both statements to combine the results. Before executing these statements, you must check that each of these select statements includes the same number of columns. In addition, all columns must contain the same data types and must be placed in the same order in both statements. Finally, click Enter to execute the query. The output places the results of both select queries into the one table that contains two columns, full name and location. These columns hold all required records for all Lucky Shrub's part-time and full-time employees. However, Lucky Shrub has two employees named Julia Marr, one who works part-time and another who works full-time. But only one Julia Marr appears in the combined set of results. This is because the union operator only returns distinct values. Yet it's interpreted both instances of Julia Marr as a duplicated value. Fortunately, you can use the union operator to generate an output that contains both employees. Just write the same select statement once again with a union operator in between. But this time, place the all keyword after the union operator. As you learned earlier, the all keyword ensures that the output retains all results from both tables, even if they're duplicate values. Finally, click Enter to execute the query. The output is then generated on screen and it contains both instances of Julia Marr. Thanks to the union operator, Lucky Shrub now have all the information they need. And having helped them out, you should now be able to demonstrate an understanding of the union operator and explain how the union operator is used in MySQL. Well done. Lucky Shrub are reviewing recent customer orders in their database. They need to find a way to group records with similar values into one single record so that they can analyze the order data and produce summaries. The MySQL group by clause and its related aggregate functions are a great way for the company to complete this task. Over the next few minutes, you'll explore these concepts and use them to help Lucky Shrub produce summaries of their orders. And by the end of this video, you'll be able to group rows into subgroups using the MySQL group by clause and utilize the MySQL group by clause with SQL aggregate functions. So, before you begin helping Lucky Shrub, let's take a moment to find out what database developers mean by the term group by. The group by clause is used in SQL syntax to group rows in a table based on given columns into summary rows, also known as subgroups. To get a better understanding of this clause, let's look at the syntax. The syntax begins with a select statement followed by the name of the required column. The from clause is then added and targets the name of the table that holds the required column. Finally, there's the group by clause. After this clause, a list of column names are added. Each one is separated by a comma. These are the columns according to which the data must be grouped. If there's a where clause in your select statement, then the group by clause must be placed after this clause. And make sure that the columns listed in the select clause include the columns listed in the group by clause. Additionally, the group by clause is also frequently used with aggregate functions. An aggregate function can be used with the group by clause to perform one or more calculations and return a single value for each subgroup. You might be familiar with aggregate functions from previous videos, but if not, don't worry. Here's a quick recap of the main aggregate functions used by database developers with the group by clause. Sum, used to add values of given columns together and return a single value. Average, used to determine the average of column values. And max, which returns the maximum value of one or more given columns. The minimum aggregate function determines the minimum value of one or more given columns. And finally, count is used to count the number of instances that a given column value occurs. Let's review the syntax of the select statement when using the group by clause with an aggregate function. First, input a select statement, followed by a list of columns. You can then apply the aggregate function on any of these columns as required. For example, you can use the max aggregate function to calculate the maximum values in column 1. Just make sure to place the column in parentheses. Next, include the from clause and the name of the table that holds the columns. Finally, include the group by clause, followed by the names of the columns by which the data should be grouped. Make sure that these same columns are also present in the select column list. Lucky Shrub can make use of the group by syntax and aggregate functions to determine the total number of orders received by each department in the business. So, now that you've learned about the group by clause and aggregate functions, it's time to use your knowledge to help Lucky Shrub. Let's start with a quick review of the order table. The table contains 5 columns: order ID, department, order date, order quantity, and order total. There are multiple records with the same value for the department column. For example, there were 5 orders placed with the lawn care department. This means that there are a total of 5 records for the lawn care department. And there are more instances of multiple records with the same value for other departments, like decking. The best approach in this instance is for Lucky Shrub to group all these records so that they have just one row for each group or department. This will make it much easier to analyze the data and produce summaries. You can help them to reduce the departments into 5 groups or subgroups using the group by clause. First, write a select statement followed by department, the column name. Next, insert a from clause followed by orders, the table name. Then add the group by clause and the name of the column. Finally, run the statement to generate the output. In the output that's returned, all records in the department column have been reduced to 5 groups, one row or one single record for each department in the business. Now that you've simplified the table, you can use aggregate functions to analyze the data. Lucky Shrub's report must show the number of orders placed with each department. You can use the count function to produce this data. The syntax for this query is almost the same as the previous one you just performed. The key difference is that you must add the count function followed by the column name in parentheses after select department. This specifies which column holds the data, and the count function counts the occurrences of each department among the order records. Now just execute the query to generate the output. The output returns the 5 departments alongside the total number of orders placed with each. Next, let's find out how much money each department made from these orders. You can use the same syntax from the previous query, but this time use the sum aggregate function with the order total column. Then execute the query. The output returns the total sum of the selected numeric column. In other words, it adds the values in the order total column for each instance of each department. Now let's determine the minimum order quantities for each department. Once again, you can use the same syntax but with the min function targeting the order quantity column. Once you run the query, the output returns the smallest value of the column. Finally, Lucky Shrub also need the average order total for each department. So write the syntax one last time. And in this instance, you can use the average aggregate function to query the order total column. The output that's returned shows the average value of the order total column. Thanks to your help, Lucky Shrub now have a summary that shows all the relevant data from the order table grouped together as required. Having proved your skills with Lucky Shrub, you should now be able to group rows into subgroups using the MySQL group by clause. And you should also know how to use the clause with SQL aggregate functions. Well done. At this stage of the course, you may be familiar with the group by clause, having helped Lucky Shrub group data from their customer orders in an earlier video. Lucky Shrub now need to filter this grouped data against a list of conditions to determine the best performing departments in the business. They can use the MySQL having clause to specify filter conditions that will generate this data. Over the next few minutes, you'll explore the having clause so that you can help Lucky Shrub. And by the end of this video, you'll be able to identify the MySQL having clause and explain its purpose, and demonstrate the use of the having clause to specify a filter condition for groups of rows. So, what is the having clause, and what does it add to your grouping data skill set? The having clause is used in a SQL statement to specify a filter condition for the group data that the group by clause generates. Let's take a moment to review the syntax for this clause, starting with a quick recap of the syntax of a typical SQL statement. As you learned in previous videos, the where clause is used in a select statement to specify one or more filter conditions, and you must place a where clause before the use of the group by clause. But the where clause can't be used to specify a filter condition for the group data that the group by clause generates. So how do you filter this data? You can add the having clause to your SQL statement. The having clause is added after the group by clause. The having clause is used to specify the filter condition that needs to be applied to your grouped data. The having clause evaluates the group filter condition against each group returned by the group by clause. If the result is true, the row is included in the result set. However, don't forget that if you omit the group by clause, then the having clause behaves just like the where clause. Let's take a quick look at a basic example of the having clause. Lucky Shrub can use the having clause with aggregate functions to determine which of their departments received orders of a certain dollar amount. Now it's time to use your new having clause knowledge to assist Lucky Shrub. As you discovered earlier, Lucky Shrub needs to filter their customer order data to check which departments met their monthly sales target of $2,275. Let's see if you can help them out. Let's begin with a review of the order table, which holds the required data. The table is divided into 5 columns: order ID, department, order date, order quantity, and order total. The first task is to identify which departments have order totals of a value greater than $2,275, so you're only concerned with the department and order total columns. You can determine the order total of each department by using a select statement with a group by clause. First, type the select clause followed by the department column. You then need to include the sum aggregate function. Then place the order total column in parentheses. Next, add the from keyword followed by the table name, which is orders. And finally, include the group by clause and target the department column. Run the statement to retrieve an output that shows the total sales figures for each of the 5 departments. Your next step is to filter this data to retrieve the results that have an order total value greater than $2,275. You can use the same statement as before, but this time add the having clause after the group by clause. The having clause is followed by a second instance of the sum aggregate function, which once again targets the order total column. Finally, use the greater than operator, followed by the figure 2275. This instructs the SQL statement to filter results greater than $2,275. This SQL statement is now ready to execute. However, you could make the syntax more efficient by using an alias. You should be familiar with the concept of an alias from previous lessons. You can use an alias called total in the select clause for the aggregate function. This alias can then be referred to in the having clause. This makes the condition concise and easier to read. Now you can execute the query. The output that's generated reveals 3 departments in Lucky Shrub which met this month's sales targets. Thanks to your assistance, Lucky Shrub has identified their best performing departments. You should now be able to identify the MySQL having clause and explain its purpose. And you should also be able to demonstrate the use of the having clause to specify a filter condition for groups of rows. You're making great progress with grouping data. Congratulations! You've reached the end of the first module in this course. Let's take a moment to recap on some of the key skills you've gained in this module's lessons. In the first lesson, you received an introduction to the course in which you learned why MySQL is a key language for database engineers and how Meta uses MySQL. And you enhanced your knowledge by reviewing some key additional resources. In Lesson 2, you explored the topic of filtering data. You began the lesson by learning about the concepts of data filtering and logical operators. You then discovered how to use logical operators to filter your data sets. Next, you completed a reading in which you explored some real-world examples of data filtering. Finally, you reviewed some additional resources on the topics of data filtering and logical operators. You then progressed to Lesson 3, in which you learned the skills required to join tables. You first learned about the concept of aliases and how they can be used in MySQL. You then learned how to identify different types of joins and how to utilize them in your database tables. And you demonstrated these new skills in a lab environment. Next, you learned about the concept of a union operator and you demonstrated its use in your databases. Finally, you enhanced your knowledge of these topics by exploring additional reading materials. In the fourth and final lesson, you gained skills in grouping data. You began the lesson by learning how to identify and make use of the group by clause. You then learned how to use a having clause. Next, you completed a reading in which you learned how to utilize the MySQL any and all operators. Finally, you were challenged to demonstrate these new data grouping skills within a lab environment. You should now be able to filter data, join tables, and group data in a database using MySQL. Great work! I look forward to guiding you through the next module in which you'll discover how to update databases and work with views. Lucky Shrub Gardening Centre are hiring some new employees. Once these new employees have been hired, the company then needs to add their contact details to the database. Some of these contact details must also replace those of employees who've recently left. The replace command is the best method for Lucky Shrub to make these changes. In this video, you'll learn how the replace command can be used to help Lucky Shrub make these changes. And once you've helped Lucky Shrub, you'll then know how to explain how the replace command works in a MySQL database and demonstrate an understanding of the replace command by inserting or updating data. Let's begin with an overview of the replace command. The replace command is used to insert or update data in a table. However, unlike the standard insert and update commands, replace first checks for a duplicate key. If found, it deletes the existing record and replaces it with the new one. So now that you know what the replace command is used for, it's time to look at the syntax. But first, let's quickly recap the syntax for the insert command. Its similarity to the replace command should help you to understand the replace command better. You should be familiar with the insert into command from the previous course. With this command, you instruct SQL to insert new values into designated columns within your chosen table. The replace command works in much the same way. You type out your table name, column names, and values just like before. The only difference is that you must begin the statement with a replace command. You can also use the replace command with the set keyword. The set clause assigns a value for the selected column, but without using the where clause to specify the condition. In other words, it locates the required record of data, then replaces the values with the new set. If you don't specify a column value in the set clause, then the replace command uses a default value or sets the value to null. The replace command is a complicated concept, and its similarity to other commands can be confusing. So, to help you out further, let's take a moment to visualize how the replace command works. As you just learned, the replace command first checks if the new record of data already exists in the table by checking the primary or unique key of existing records. If there's no matching key, then replace works like a normal insert statement and adds the new data. If a matching key is found, then the command deletes the existing record and replaces it with the new one. Now that you're familiar with how the replace command works, take a few moments to see if you can help Lucky Shrub insert and replace new and existing employee records in their database. Lucky Shrub's employee contact records are stored in the Employees Contact Info table. The table consists of 3 columns: the employee ID, which is the primary key, the contact number, and email address columns. You need to insert a new record of data for the new employee Seamus Hogan with the following details: an ID equal to 1, a contact number, and an email address. You can add this data to the table using the standard insert command. Just type insert into followed by the table and column names. Then add the values to be inserted into each column: ID, contact number, and email address. Click enter to execute the query. The new employee record is added to the table. You can do the same with the replace command for the employee Thomas Erickson. Begin with the replace into command, followed by the table and column names to be updated. Then use the values keyword and list the values to be added to the table for Thomas. These values are his ID, contact number, and email address. Click enter to execute the query. You can then use a select statement to check the table's records. The output shows that Thomas's contact details are now in the table, as are those of Seamus. However, Seamus has decided to leave Lucky Shrub to work for a rival gardening centre. So, you now need to replace his details with those of a new employee, Maria Carter. You can try updating the table using the insert command. Type an insert into statement just like before, and assign Maria an ID of 1 in your statement's values, alongside her contact number and email address, so that her records replace those of Seamus in the table. Then execute the query. But it looks like SQL can't execute this query. Instead of adding Maria's details to the table, it's returned an error message warning of a duplicate entry. This is because you're trying to assign Maria an ID of 1. But this ID is already assigned to Seamus as a primary key value. The primary key must always have a unique value in each row of the table. Otherwise, MySQL returns an error message. So, how can you replace Seamus's records with Maria's? Type the statement again, but this time use the replace command instead of insert. Then click enter to execute the query. MySQL has accepted the statement with no errors. Let's query the table to make sure it contains Maria's records. Type a select statement and from keyword followed by the table name. Then click enter to execute the query. The output returns the contact details for Maria and Thomas. MySQL has replaced Seamus's records just like you instructed. There's one more task to complete. Maria has recently changed her contact number, so the number also needs to be updated in the table. You can use the replace command to update the record of data. Type the replace command and the table name. Then use the set clause with Maria's employee ID of 1, followed by the new value, which is her contact number. But make sure that you set values for all columns. Otherwise, they'll be set to null or default values. Press enter to execute the query. You can use a select statement to check the table and confirm that Maria's details were updated. Thanks to your efforts, Lucky Shrub's employee contact info is now up to date. You should now be able to explain how the replace command works and demonstrate the replace command by inserting or updating data. Great work. Little Lemon Restaurant have built 2 new tables in their database that allow customers to create accounts and register bookings. To make sure that these tables work as required, the restaurant has set up constraints which ensure that the tables only accept valid data. Over the next few minutes, you'll learn about the concept of constraints in MySQL by exploring how Little Lemon have made use of them in their database. And by the end of this lesson, you'll be able to identify the main types of constraints and explain how they function, and explain the MySQL on delete cascade and on update cascade options. Let's begin with an overview of what database engineers mean by the term constraints. When creating a table, you might decide that each column must hold a unique value in each row of the table, like a phone number. You can enforce this rule using the unique constraint, which prevents any violation of the rule whenever data is inserted or updated in your database. There are 3 main types of constraints in MySQL database which can be used to enforce these rules. Key constraints, which apply rules to key types. Domain constraints, used to govern the values that can be stored for a specific column. And referential integrity constraints, which establish rules for referential keys. Let's take a few moments to explore each of these 3 MySQL constraint types and discover how they're used by Little Lemon in their database. As you learned in the previous course, all tables include different types of keys, like primary keys and foreign keys. You can use constraints to establish rules for these keys. For example, the primary key constraint can be used to specify that 1 or more column values must always be unique, and they cannot accept a null value. Little Lemon's database contains a table called Customers. This table records key data on customer bookings using the primary key constraint. The table has 3 columns called Customer ID, Full Name, and Phone Number. Customer ID is defined as the primary key which returns data on the table's unique records. Thanks to the primary key constraint, this column's values must always be unique and it can never accept null value. In other words, every row in the column must hold a customer ID and all customer IDs must be unique. Next, let's look at domain constraints. As you learned earlier, these are special rules defined for values that can be stored for a certain column. Little Lemon's database contains a bookings table that records data on customer bookings. However, the restaurant can only facilitate a maximum of 8 guests per booking. So they enact the SQL check constraint on the number of guests column. This limits the value range that can be placed in the column, which means the table rejects any numeric values greater than 8. Finally, let's explore referential integrity constraints. You learned earlier that this type of constraint establishes rules for referential keys. But how exactly does this work? Basically, in a referential integrity constraint, there are 2 types of tables. A referencing table that holds a primary key and a referenced table that contains a foreign key. The value of the foreign key column that exists in the referencing table must always exist in the referenced table. Otherwise, a connection can't be established between the 2 tables. To understand this better, let's explore the example of the related tables in Little Lemon's database in the form of an entity relationship diagram. Little Lemon's database includes 2 related tables. The customers table that holds data on customers and the bookings table that records information on customers' bookings with the restaurant. Each booking in the booking table must relate to a specific customer in the customers table. Otherwise, the restaurant can't identify who made the bookings. And this also means that each customer must already be registered in the customers table before they can make a booking in the bookings table. The customer ID column in the bookings table is defined as the foreign key. This is the attribute that joins the 2 tables together and establishes dependency between them. This means that if a row of data is altered or deleted in the customers table, then this action destroys the related row of data in the bookings table. In other words, deleting a row of data from the customers table violates the referential integrity rule. And this results in an error message from MySQL warning that the action directly impacts on the bookings table. So, how can you make the required changes to the bookings table without violating the referential integrity constraint? In this instance, you can use the onDelete cascade option. This option automatically deletes the related rows of data from the bookings table. And if you want to update a primary key value in the customer's table, you can use the onUpdate Cascade option to automatically update the related rows in the bookings table. You'll discover more about these options in a later video. You should now be able to identify the main types of constraints and explain how they function. And you should also be able to explain the MySQL onDelete Cascade and onUpdate Cascade options. Well done. Little Lemon Restaurant need to build 2 tables in their database that let customers create accounts and register bookings. They also need to apply constraints to the columns in these tables to ensure data consistency and integrity. Over the next few minutes, you'll help Little Lemon create these tables and apply the following common constraints: not null, unique, check, and foreign key. And by the end of this video, you'll be able to demonstrate how to apply these common constraints in a MySQL database table. The first table that must be created is customers, which records customer details. And the table requires the following constraints: the primary key constraint on the customer ID column, the not null constraint on the full name column, and a unique constraint on the phone number column to ensure that each customer has a unique number. So let's get started. Begin with the create table command and call the table customers. Then add a pair of parentheses. Within the parentheses, define the customer ID column as not null and as the primary key. This ensures that all IDs are unique in each row of the table and that the column does not accept a null or empty value. Next, add a full name column with the constraint not null. And assign a value of varchar with a character limit of 100. Then declare the phone number column as not null unique. This ensures that it only accepts a unique number for each customer. Finally, execute the statement. Now let's view the output by writing and executing the following statement: show columns from customers. This shows the customers table. The table contains all relevant constraints. The columns are defined with not null. 2 keys have been declared. The customer ID column is the primary key, and the phone number column only accepts unique values. The next task is to apply referential integrity. This ensures that each customer can make a booking in the restaurant and that each booking must be assigned to a specific customer. In other words, any customer ID that exists in the bookings table must also exist in the customers table. Otherwise, it won't be possible to identify who made the bookings. When creating the bookings table, it's important to focus on the referential integrity constraint and the check constraint to limit the number of guests to a maximum of 8. Begin with a create table command, followed by bookings and parentheses. In the parentheses, create the following columns: booking ID, booking date, table number, number of guests, and customer ID. All columns are defined as not null to ensure that each one must accept a value. All columns are also assigned the integer value, except bookings date, which is assigned a date value. The booking ID column is defined as the primary key. The number of guests column is defined with a check constraint that specifies it's not null. And use a smaller than or equal to operator so that it can only accept a maximum of 8 guests. Next, define the customer ID column with the foreign key constraint. Then use the references constraint so the foreign key references the customer ID column in the customers table. Now use onDelete and onUpdate Cascade options to delete and automatically update the related rows of data in the bookings table. However, be aware that these actions depend on the update and delete operations taking place in the customers table. Click Enter to execute the statement. To display the table structure, type the following syntax: show columns from bookings. The output set result shows all columns are assigned the required constraints and values. And the customer ID column is null. This means that it's not a unique key and multiple rows can have the same key value. This makes sense because each customer might make multiple bookings at the same or at different times. This code also joins the 2 tables and establishes dependencies between them. So if you change or delete the customer ID in the customers table, then you also update or delete the related record in the bookings table. You should now be able to apply different types of constraints in MySQL database to maintain data integrity and consistency. Great work. Lucky Shrub Gardening Centre has bought new heavy machinery, but it can only be operated by qualified employees. The business has a database table called Machinery that records the contact info of all qualified employees. However, the table has issues with its constraints, and it's also missing some key information. Lucky Shrub can fix these issues by making alterations to the table using the alter statement. Over the next few minutes, you'll learn about the alter statement and then use what you've learned to help Lucky Shrub alter their database. And by the end of this video, you'll be able to add, delete, and modify columns and constraints in an existing table. Let's begin with an overview of the alter statement and its syntax. You might often encounter tables in a database that contain missing columns or constraints, or their existing columns and constraints may need to be modified. You can use the alter table statement to make these changes. The alter table statement is often used alongside different SQL commands. Here's a quick overview of some common commands used with the alter table statement. The modify command is used to target specific columns and instruct SQL to make changes to them. The add command can be used to add a new column to a table, and the drop command can be used to drop or delete a column from a table. So, how are these commands used to make alterations to a table? The alter table statement begins with the alter and table clauses, followed by the name of the table to be altered. Next, insert a modify command, followed by the name of the column to be altered and the changes to be made. For example, you can change a column's data type and add a not null constraint. Then repeat the modify command for all other columns you want to alter. You can also alter a table by adding another column. Just use the add column command, followed by the name of the new column. To remove a column from a table, just use the drop command, followed by the name of the column you want to drop or delete. Now that you're familiar with the alter table statement, see if you can help Lucky Shrub make the required changes to their table. The tasks that Lucky Shrub need to complete are as follows. Set the employee ID column as the primary key, change the column constraints, and add a new column to the table. Let's get started. Lucky Shrub's machinery table includes 4 columns: employee ID, full name, phone number, and county. The table is missing a primary key. Fortunately, the employee ID column is the perfect candidate because all values are unique. To set this column as the primary key, you can write an alter table statement. Add the alter table clauses followed by the table name. Then write the modify command and the employee ID column name. Next, set the data type as varchar with a character limit of 10. Then set a not null value to ensure that the column always contains data. Finally, add the primary key value to the column. The employee ID column is now the table's primary key. It looks like each column in the table is also set to accept null values. This means that the table can contain empty fields or rows, which is poor practice in a database. So, to change all columns to not null, you can write another alter table statement. In fact, you can use the same statement as before and just add a new line for each column. For the full name and county columns, you can write the following syntax. Add a modify command, set the varchar data type to 100 and a value of not null. For the phone number column, you can write the same syntax but with integer and unique values. This means that the column now accepts unique numeric values only. This avoids any duplicate values. To view the new table structure, write the following statement. Show columns from machinery. This query's output shows that the employee ID is now set as the primary key, the phone number is a unique value, and all columns are set as not null. Now, your final task is to add a new column to the table. Lucky Shrub's machinery can only be operated by employees aged 18 and over. So, the company needs to identify each employee's age and determine who is old enough to operate the machinery. There's currently no age column in the table, so you'll need to create it and add a constraint to ensure every new employee added to the table is at least 18 years old. You can write the statement as follows. Alter table followed by the machinery table name, then the add column command. Next, call the new column age and assign it an integer value. Finally, use the check function to limit the values in this column to at least 18 or more. Then click Enter to execute the query. To view the table's new structure, write Show columns from machinery. The output now displays the machinery table with a new age column. Thanks to your help, all the required changes have now been made to Lucky Shrub's machinery table. You should now be able to use the Alter Table clause to add, delete, and modify columns and constraints in an existing table. Great work. Lucky Shrub are planning an overhaul of their database. In preparation, they want to create copies of their data to keep it safe during the rebuild. They can complete this task using the copy table process. Over the next few minutes, you'll learn about the process for copying a table and then help Lucky Shrub to copy tables in their database. And by the time you complete this video, you'll have learned how to copy data from an existing table to a new table within the same database, copy a table to a new location while ensuring it retains its constraints, and copy data from an existing table to a new table from a different database. These tasks are carried out using the create table syntax. However, before you explore this syntax, let's take a moment to review the process for copying tables. It's important that you're familiar with the process before you begin copying tables. You first need to identify the database and the table you want to copy the data from. Next, determine the columns you want to copy, either all columns or just some of them. Then, use the create table statement to build a new table with a relevant table name. And finally, use the select command to structure the new table by specifying the columns you want to copy data from. Now that you're familiar with the process steps, let's review the create table syntax. The copy table SQL statement begins with the create table command, followed by the name of your new table. Next, write the select command, then identify the columns to be copied. You can copy one, several, or all columns. Finally, use the from command, followed by the name of the existing table you want to copy. But what about copying a table between two different databases? Once again, begin with a create table command. However, in this instance, you must use dot notation to identify the names of the new database and table. Then use the select command to select the existing table's columns. And finally, use the from clause. Then follow this with another instance of dot notation that identifies the names of the existing table and database to be copied. Lucky Shrub are now ready to begin copying tables in their database. They want to carry out the process as follows. First, they need to copy the clients table to a new table called clients test in the same database. They then need to copy a few select columns to the table. Next, they need to make sure that all constraints from the original table were copied over to the new one. And finally, they want to copy a table from one database to another. Use your new knowledge of the copying tables process to help them out. First, let's review the clients table in the Lucky Shrub database by typing select * from clients. Then click enter to execute the query. This generates the client table on screen. The table contains 4 columns: client's ID, full name, contact number, and location. For the first part of the test, Lucky Shrub need to copy the clients table to a new table called clients test in the same database. You can perform this task using the create table SQL query to create 2 statements. In the first statement, use a basic create table clause to create the new client test table. In the second statement, type the select command with the asterisk as shorthand for all columns. Then type the existing table name, which is clients. Finally, click enter to execute the query. This query copies all columns and their data from the clients table to the new clients test table. To check that the query was successful, you can type the following statement: select * from client test. Then click enter to execute. This query generates the clients test table, and the table contains a copy of all the data as required. Next, Lucky Shrub needs you to copy partial data only. They need to copy the full name and contact number columns from the clients table to another table. Begin with a create table statement, followed by the name of the new table, which is client test 2. Then use a select command. But in this instance, specify just the full name and contact number columns. Type the from keyword, followed by the name of the existing table, which is clients. Finally, use the where clause in the select statement to specify a condition. In this case, copy the data only for those employees who live in Pinal County. Click enter to execute the query. The query's output shows the clients test 2 table. And the table contains a copy of all the data from client test for all employees from Pinal County. The test worked. Next, you need to make sure that all constraints from the original table were copied over to the new one. It's important to remember that copying data using the methods you've encountered so far doesn't copy the key constraints. You can check the constraints on the original table by typing and executing the statement, show columns from clients. The query generates the clients table. The table structure shows all columns with the key constraints set for the client ID and contact number columns. Now let's check for these constraints on the client's test table by typing and executing the following statement. Show columns from client's test. This statement shows the client's test table. The table is missing the primary and unique keys defined in the original table. So how can you copy these keys? You can use the following statement. Create table clients test 3 like clients. The like keyword creates an exact copy of the existing table structure. Press Enter to execute the statement. Then type and execute the following SQL statement to display the new table structure. Show columns from clients test 3. The output shows an exact copy of the initial clients table, and all the key constraints have been copied as expected. Your final task is to copy the clients table from the Lucky Shrub database to the new test database. Begin with a create table statement. Then specify the new database and table names as testdb.clientstest. Type select asterisk to instruct SQL to copy all data. And finally, add the from keyword followed by the existing database and table names, which are luckyshrub.clients. Click Enter to execute the query. Now you just need to check that the query was successful by moving into the test database. Type testdb, then show tables to reveal all tables in the test database. This statement reveals all the tables created in the test database, including the client's test table you just copied over from the Lucky Shrub database. And the table contains all the data from the original one. Lucky Shrub now have all the required copies of their tables in their database. You should now be able to copy data from an existing table to a new table within the same database, copy a table to a new location while ensuring it retains its constraints, and copy data from an existing table to a new table from a different database. Great work. Little Lemon Restaurant need to extract financial info from their database to complete their accounts. They can carry out this task using a subquery. Over the next few minutes, you'll explore the concept of a subquery and learn how to recognize a subquery and understand its syntax, identify scenarios in which a subquery can be used, and explain how subqueries are used to retrieve data. So, to begin, let's answer the question of, what is a subquery? As the name states, a subquery is a query within another query. In other words, it's an inner query placed within an outer query. The inner query is viewed as the child query and the outer query as the parent query. But what does a query within a query look like? Well, the best way to understand a subquery is through its syntax. As you just learned, a subquery is a query within a query, an inner or child query within an outer or parent query. The inner query or subquery executes first, and its results are then passed to the outer or parent query. You can also build multiple subqueries in MySQL. The outer query is presented like any normal query. It contains select, from, and where clauses. Likewise, the subquery is written as a standard query. However, the subquery must always be placed within a pair of parentheses. When executed, a subquery can return any of the following results: a single value, a single row, a single column, or multiple rows of one or more columns. A key advantage of a subquery is that you can compare it against other values using a comparison operator. You should be familiar with comparison operators from previous lesson items in this specialization. If not, here's a quick recap. Examples of commonly used standard comparison operators include equal to, less than, and greater than. There's also less than or equal to, greater than or equal to, and not equal to. Let's look at the syntax for subqueries and comparison operators. A subquery can be placed before or after a comparison operator in the where clause of your parent query. Now that you're familiar with the basics of subqueries, here's a demonstration of how they're used. Little Lemon Restaurant are reviewing their accounts and need employee salary data from their database. This data is held in the Employees table. The table contains 4 columns: Employee ID, Employee Name, Role, and Annual Salary. Little Lemon must use this table to identify which employees earn a salary higher than that of the assistant chef. You can use a subquery to complete this task. This query can be completed in 2 parts as follows. The outer or main query must extract details of all employees whose annual salary is greater than the specified value, and the subquery must identify the annual salary of the assistant chef. When executed, the subquery provides a subset of data from the employee's database, and this subset of data is then used as an input for the outer query. Begin by writing the outer query as follows: a select command followed by an asterisk, then the from clause, which targets the employees table. The next part of the outer query must filter out the employees table data based on the annual salary. So, add a where clause followed by the annual salary column. Then add the filter condition in the where clause, the annual salary column, followed by a greater than operator symbol. The greater than operator must target a specific value. But how do you determine what this value is? You can use a subquery. Write a subquery within your main query as follows. Add parentheses after your greater than operator. Within the parentheses, write select annual salary column from employees table. Then write a where clause, followed by the role column. Finally, add an equals operator followed by the assistant chef value. Now that you've written both queries, press enter to execute. The subquery executes first and extracts the annual salary of the assistant chef. This value is now the input for the outer query's where clause. Next, the outer query is executed. The outer query's where clause filters out the records of all employees earning an annual salary greater than that of the assistant chef. In other words, the outer query filters out the values greater than the value retrieved by the subquery. The subquery's result shows that the assistant chef earns $45,000 a year. And the outer query shows that there are 3 employees who earn more than the assistant chef. These employees are the manager, assistant manager, and head chef. And that's an example of how the subquery is used in a database. You should now be able to recognize a subquery, understand its syntax, and identify scenarios in which a subquery can be used. Well done. Little Lemon Restaurant need to perform complex queries in their database, and standard subqueries might not be enough for this task. So they'll need to use multiple row subqueries with complex comparison operators. Over the next few minutes, you'll explore subqueries and complex comparison operators and learn how to explain how subqueries interact with complex comparison operators, and demonstrate the use of subqueries in a complex data retrieval scenario. As you might already know, a key advantage of a subquery is that you can compare it against other values using an operator. However, there are more complex operators that can be used with multiple row subqueries. The any operator returns data for any values that meet the specified condition. All returns data for all values, and the sum operator returns data for one or more matching values. Let's look at how to write multiple row subqueries using the all, any, and sum operators. These comparison operators let you perform a comparison between a single common value and a range of other values. They result in multiple records or target multiple values within a table. Subqueries can also be used with the exists and not exists operators. The exists operator tests for the existence of rows in the results set returned by the subquery. It returns true if the subquery returns one or more records. On the other hand, the not exists operator checks for the non-existence or absence of results from the subquery. Not exists returns true when the subquery does not return any row of results. Let's review the syntax for the exists and not exists operators. The syntax is very similar to a standard subquery. The key difference is that the exists operator is placed after the where clause to determine the existence of the value specified in the subquery. Or you can use the not exists operator to check for the non-existence or absence of results from the subquery. Let's look at a demonstration of how subqueries are used with these operators. The Little Lemon restaurant need to identify all employees earning an annual salary that's less than or equal to the annual salary earned by all employees in the following roles: manager, assistant manager, head chef, and head waiter. The data required to complete this query is in the employees table. The table has 4 columns as follows: employee ID, employee name, role, and annual salary. You can extract the data required from this table using 2 queries. An outer query to identify all employees who are earning an annual salary that's less than or equal to the specified values, and a subquery that extracts the data of annual salaries earned by employees who are in the roles specified earlier. Let's begin with the outer query. It starts with a select command and an asterisk. Then add a from clause that targets the employees table. Next, write a where clause followed by the annual salary column name. Finally, write a less than or equal to operator. Now you must write the subquery within parentheses. Write a select command to select the annual salary column. Then a from clause to target the employees table. Next, write a where clause followed by a condition that extracts data from the role column. Finally, in parentheses, write the required roles: manager, assistant manager, head chef, and head waiter. These queries must return a result that lists all employees earning an annual salary that's less than or equal to the annual salary earned by all employees in the role specified. So, to ensure that you get the desired result, place the all operator after the less than or equal to comparison operator, but before the subquery. Then execute the query to return the output. The subquery executes first and identifies the salaries of the manager, assistant manager, head chef, and head waiter roles. These salaries are the values that the outer query uses. The values are 70,000, 65,000, 50,000, and 40,000. So the outer query filters out the employees who earn an annual salary less than or equal to all these values. The final output shows that the employees with IDs of 5 and 6 earn an annual salary less than or equal to the other roles. On the other hand, the any operator compares the results of the subquery to determine whether it can exclude records from the outer query that satisfy the conditions for any of the values returned by the subquery. Little Lemon's next task is to identify employees earning an annual salary that's greater than or equal to the annual salary earned by any employee in the 4 roles specified earlier. You can use the same query as before, but remember that this time you're checking for values that are greater than or equal to those in the subquery. So change the comparison operator in the where condition of the outer query to a greater than or equal to operator. Now, just before the subquery, replace the all operator with the any operator. Finally, press enter to execute the query. The output shows that there are 5 employees who earn a salary greater than or equal to the other roles. For their final query, Little Lemon needs to determine if their head chef and waiter are assigned to a booking. They can do this using the exists or not exists operators. The query involves 2 actions. In the first action, the outer query extracts details of employees, and in the second action, the subquery determines if the head chef or head waiter have been assigned to a booking. The required data is held in the bookings table. This table has 6 columns as follows: booking ID, table number, first name of guest, last name of guest, a column for each booking slot or time, and a column that shows the ID of the employee assigned to the booking. Begin by writing the outer query as follows: select asterisk from employees. Then add a where clause. The subquery must determine if there are any employees in the role of head chef or head waiter assigned to a booking. So add the exists operator after the where clause. Then write the subquery in parentheses as follows: a select command and an asterisk. a from clause targeting the bookings table, a where clause, and a condition that must return results for the required employees if they're assigned to a booking. Press Enter to execute the query and generate the output. So the exists operator has checked for the existence of the specified results in the subquery, and it has found that these results exist. Therefore, the operator result is true. The result is that the outer query filters out the details of the 2 employees who are assigned to these 3 bookings. Now, let's replace exists with the not exists operator to see what results are returned. The output returns the same 3 records as before. However, the not exists operator checks for the non-existence of results from the subquery. Also in this case, the where clause filters out employees that do not exist in the results obtained by the subquery. This returns the results of 4 employees that don't exist in the subquery's results. In other words, this is the data for employees who don't meet the subquery's criteria and aren't identified in the results. You should now be able to explain how subqueries interact with comparison operators and demonstrate the use of subqueries in a complex data retrieval scenario. Well done. Lucky Shrub have had particularly good sales so far this year. They now need to identify the top 3 best-selling products to make sure they have enough quantity in stock for the next few months. There's a lot of data to parse through in their database, so they've decided the easiest way to identify the best-selling products is with the use of a virtual table or view. In this video, you'll explore views and then use what you've learned to help Lucky Shrub. And by the end of this video, you'll be able to explain the concept of views in database and demonstrate how to create, rename, and drop views in MySQL database. Let's begin by developing an understanding of what database engineers mean by the term views. Views are virtual tables created from one or multiple tables depending on the requirements. The view presents a table interface that lets the database users access and manipulate the data within the table using MySQL. So why do database engineers use views? Let's look at some common use cases. Views can be used to create a subset of a table's data. For example, a table might have 7 columns, but you only need data from 3. So you could create a subset from these 3 columns. And views can also be used to combine data from multiple tables. You might need to query 2 columns from one table and 4 from another. You can use views to combine both sets of columns into one virtual table. Now that you understand what views are, let's review the syntax. The syntax begins with the create command, followed by the view keyword and the name of the view or virtual table. The as keyword is then used to define the view table functionality. Next, use the select command to specify the columns the table must be built from. You can specify these columns using dot notation, making sure to include both the table and column name. For example, table1.column1 to select the first column in the first table. Then use the from keyword to specify the tables that the data must be extracted from. Finally, you can use the where clause and a condition to set data order and filtering rules. That's how you can create a view by extracting data from one table. However, creating a virtual view based on multiple tables requires a bit more effort. Let's find out more. When creating a view from multiple tables, much of the syntax remains the same. The key difference is after the select command. You must list the columns that you require from both tables using dot notation. You then need to create an inner join after the from keyword in which you join the 2 tables together. Then use the on keyword to determine the matching columns used to create the join. Let's take a closer look at the use of dot notation. Dot notation is used to link columns with tables. This is particularly important if you're dealing with multiple tables. Multiple tables might give rise to a potential conflict in names. For example, 2 tables could use the same name for a specific column. To avoid this, you can establish a link between each column and its respective table by placing a dot in between them. However, dot notation is optional if your query is only dealing with one table. The view syntax presents a clear 5-step process for creating a virtual table or view. Create the virtual table using the create view syntax. List the columns to be moved from the original table to the virtual one. specify the original table from which data must be extracted to create the view, set the conditions, and finally, set the data order and filtering rule. Now that you've been introduced to what a view is and been shown how to create one, it's time to see if you can assist Lucky Shrub. As you discovered earlier, Lucky Shrub need to identify their top 3 best-selling products with the use of a virtual table or view to make sure they have enough quantity in stock for the next few months. Let's use your new knowledge of views to help them out. You can create a virtual table or view for Lucky Shrub using the data in the orders and products tables in their database. Let's take a moment to familiarize ourselves with these tables before using them to create the view. The orders table has 5 columns that include information about the order ID, client ID, product ID, quantity, and cost. While the products table has 3 columns that include information about the product ID, item name, and price. Lucky Shrub want to identify their top 3 best-selling products. So to create the view, you only need data from the item name column from the products table, the order quantity, and total cost columns from the orders table. As you learned earlier, the key steps for creating the view lie in the syntax. So write a create command and the view keyword. Then write the name of the view, which you can call top 3 products. Include the as keyword to define the view table's functionality. Then use the select command and dot notation to target the required columns for your view. Next, use the from keyword to identify the tables. However, the view is created from 2 separate tables. So you'll need to join these tables together using inner join based on their matching product ID value. Finally, use order by to list the products based on the highest cost, with only the top 3 products appearing on screen in descending order. Execute the query to generate a new virtual table called top 3 products with the 3 required columns, item, quantity, and cost. You can now query this virtual table just like any other normal table using the following basic SQL statement. Select asterisk from top 3 products. The table prints the top 3 best-selling products along with their name, quantity, and cost. Why don't you try renaming the table to something shorter, like top products? You can rename a virtual table using the MySQL rename command. To rename the table, write rename table, top 3 products to top products. This syntax is used to rename all types of tables in MySQL. In this statement, you just specify the view's current name after the rename table clause. Then you specify the view's new name after the to keyword. Finally, click enter to execute the query. The table has now been renamed top products. What if you no longer require a virtual table? You can just drop it using the SQL drop command, drop view top products. Click enter to execute the query. The view has now been removed and there's no impact on the original table it was created from. Thanks to the view, Lucky Shrub now know what their top 3 best-selling products are, and they can make sure that they have enough quantity in stock for the next sales period. You should now be able to explain the concept of views in database and demonstrate how to create, rename, and drop views in MySQL database. Well done. Congratulations, you've reached the end of the second module in this course. Let's take a moment to recap on some of the key skills you've gained in this module's lessons. In the first lesson, you learned how to insert and update data and should now be able to explain the concept of the replace statement, outline how the replace statement is used to insert or update data in a database table, and demonstrate the replace statement following your completion of the projects in the lab environment. In Lesson 2, you learned how to work with values and constraints. Now that you've completed this lesson, you're able to identify the main types of constraints, explain how constraints work in a database, outline the MySQL on-delete cascade and on-update cascade options, and demonstrate your ability to utilize values and constraints as proven in the lab environment. You then moved on to the third lesson in which you learned how to change the structure of a table. Having completed this lesson, you're now able to add, delete, and modify columns and constraints in an existing database table, Copy data within and between tables and databases using the copy table syntax. You also demonstrated your ability to alter tables in the labs, and you reviewed the additional resources to learn more about these concepts. In the fourth lesson, you explored the concept of subqueries. Now that you've completed this lesson, you're able to recognize a subquery and understand its syntax, identify scenarios in which a subquery can be used, and explain how subqueries can be used to retrieve data. You also demonstrated your ability to work with subqueries in a lab environment. Finally, in Lesson 5, you learned about virtual tables or views. Now that you've reached the end of this lesson, you're able to explain the concept of views in a database, demonstrate how to create, rename, and drop views in a database, identify the advantages of using views in MySQL, and you completed readings in which you gained additional knowledge on the topics of views. Having completed this module, you should now be able to update data, work with values and constraints, change the structure of a table, and utilize subqueries and virtual tables. Great work. I look forward to guiding you through the next module in which you'll discover how to work with functions and MySQL stored procedures. The jewelry store Magenta and Gallo, also known as M&G, are reviewing client orders in their database. They must determine the average amount of money that each client has spent with the business. M&G can use numeric functions to extract this information. In this video, you'll explore numeric functions and learn how to identify common MySQL numeric functions and explain how these functions are used to process and manipulate data in a MySQL database. At this stage of the course, you've encountered some basic functions. So here's a quick reminder of what database engineers mean by the term functions in the context of MySQL. As you've learned in earlier lessons, a function is a piece of code that performs an operation and returns a result. Some functions accept parameters or arguments, while other functions do not. Functions are very useful for manipulating data in a database table. Broadly speaking, MySQL functions can be grouped into 5 different categories as follows: numeric functions, string functions, date functions, comparison, and control flow functions. You'll review each of these functions in more detail over the course of this lesson. The focus of this video is MySQL numeric functions, which can be divided into 2 categories: aggregate functions, which can be used on a set of values, and math functions, which perform basic mathematical tasks on data. You should already be familiar with aggregate functions, having used these previously in the course with select statements to calculate aggregated values. So let's just recap them briefly. Commonly used aggregate functions include sum, average, and max. There's also the minimum aggregate function and count. Now that you've recapped aggregate functions, let's look at some common math functions. A number can be rounded to a specific decimal place using the round function, and the mod function can be used to return the remainder of one number divided by another. These functions are a great way for M&G to perform additional tasks while also determining the average dollar amount that each client has spent with the business. But how can you and M&G make use of these functions in a MySQL database? You can build them into your SQL select statements. Let's review the syntax. The round syntax begins with a select command, followed by the name of the column to be queried. You then call the round function, followed by a pair of parentheses. Within these parentheses, write the required arguments. The first argument can be a column name or any numeric value. The second argument must be the number of decimal places. Finally, write the from keyword, followed by the required table name. The mod syntax is very similar. Just call the mod function instead of round. And within parentheses, identify the column or value and instruct MySQL what number to divide the value by. Finally, identify the table that holds the data. When working with the mod function, bear in mind that the first argument can be a table column or any numeric value, while the second argument must be the value by which the first will be divided. For example, M&G can use the round syntax and average numeric function to determine the average dollar amount each client spent rounded down to 2 decimal places. Let's take a few moments to explore M&G's database and find out more about how they make use of numeric functions. As you learned earlier, M&G are reviewing client orders and must determine the average dollar amount that each client has spent with the business. The company has a table called Client Orders that shows the average amount each client has spent. The table has two columns, Client ID, which shows the ID of each client, and Average Cost, which displays the average amount each client has spent. However, even though this table shows the average amount, M&G need to round down these values to 2 decimal places. You can help them using the round function. Write select followed by the column names. Then call the round function on the average cost column. In parentheses, put the average cost column as the first argument. Then pass the number 2 as the second argument to round the value to 2 decimal places. Next, use the from keyword to target the client orders table. Finally, group by client ID. Execute the query to create the output and display all decimal places reduced to 2. In the next task, M&G are restocking their inventory and need to identify which items they've placed an even number of orders for. The data they need is in the table MG Orders. The table contains several columns, but the ones you need to complete this task are Order ID, Item ID, and Quantity. To determine if a given quantity is odd or even, you can divide the quantity by 2. The remainder is your answer. This can be done using the mod function. First, write select followed by the column names. Then call the mod function. Pass the quantity column as the first argument and the number 2 as the second argument. Execute the query. The query returns the following values. A value of 0 if there is no remainder when all data is divided by 2, or it returns just the remainder value. The output shows that an even number of orders have been placed for items 1, 3, 5, and 6. M&G have now completed their database tasks using common MySQL functions. And you should now be able to identify frequently used MySQL numeric functions, and explain how these functions contribute to data processing and manipulation in a MySQL database. Well done. Magenta and Gallo, or M&G, are performing an inventory review. They require a list of item names and their available quantities. They can extract this data from their database using common MySQL string functions. Over the next few minutes, you'll learn how string functions can be used to perform tasks like this. And by the end of this video, you'll be able to identify common MySQL string functions, and explain how these functions are used to process and manipulate data in a MySQL database. Let's take a moment to find out what database engineers mean by the term string functions. String functions are used to manipulate string values. For example, adding strings together or extracting a segment of a string. Here's a few examples of some commonly used string functions. The concatenation function is used to add several strings together. And there's also the substring function, which extracts a segment of a string from a parent string. Uppercase converts a string to uppercase, and lowercase converts a string to lowercase. Next, let's explore the syntax of these strings to find out how they're used in a MySQL database. A very simple example of a concatenation function begins with a select command, which calls a concatenation function. You then type a pair of parentheses in which you include the string values to be concatenated. Ensure both are contained within double quotes and separated by a comma. Then include the from keyword and the name of the table that contains the data. You can also use the where clause to specify a condition. A more complex example of the concatenation function might involve extracting string values from 2 separate tables. For example, the data that M&G require is on 2 separate tables, items and MG orders. M&G can pass their arguments in the select clause, identify the 2 tables they required in the from clause, and specify the condition in the where clause so that SQL filters the required data from the combination of the 2 tables. This example might seem complicated, but don't worry. You'll explore it in more detail in a few moments when you help M&G query their database. Let's continue to review string function syntax with substrings. The syntax of a substring function is similar, but there are 3 arguments contained within the parentheses. The first of these is the string itself. The next one is the start index. the point in the string at which the substring must begin, and length refers to the length of the string portion that must be extracted. Next, let's review the syntax for the uppercase and lowercase string functions. M and G often convert the values in one column of a table to uppercase and the values in a second column to lowercase. Here's how they perform this task. An uppercase string function begins with a select statement and uppercase function. In parentheses, write the name of the column whose values must be converted to uppercase. Finally, instruct SQL which table to target. A lowercase string function is very similar. The only difference is that the parentheses must contain the name of the column whose values are to be converted to lowercase. Next, let's look at how M and G make use of string functions in a MySQL database. As you learned earlier, M and G need a list of item names and their available quantities ordered in the format item name order quantity. The item details are in the items table and the order details are in the MG orders table. The items table records information on items in M and G's inventory within the following columns: item ID, name, and cost. The MG orders table records data on deliveries within the following columns: order ID, item ID, quantity, cost, order date, delivery date, and order status. You can extract the required data from these tables using the concatenation string function. Begin with a select command, then call the concat function and write a pair of parentheses. Within the parentheses, pass the arguments name and quantity. These are the names of the columns for your output. These columns stand for the items table and MG orders table, respectively. Then add a hyphen in between the arguments to combine them. Use a pair of single quotes for the hyphen and ensure all arguments are separated by commas. Use a from keyword to specify the two tables. Finally, use a where clause to specify a condition that filters the required data from the combination of the two tables. Then execute the query. MySQL extracts a table that shows the total quantity of each item in the inventory. The next task is to retrieve all string values in the order status column of the MG orders table in both upper and lower case. You can target the string values from the order status column using the upper and lowercase string functions. In your select query, call the uppercase function and pass in the column name order status. Then target the MG orders table with the from keyword. Execute the query to retrieve all values in uppercase. To retrieve all values in lowercase, just type the same query again, but this time call the lcase function. Execute the query once more to retrieve all values in lowercase. As part of their next task, M and G are reviewing an order from a client. They need to extract the first name of this client from the clients table. The clients table records key information on clients and stores it in the following columns: the client ID column, in which the required client is assigned an ID of 1, the client name, address, and contact number columns. You can retrieve the information M and G need by using the substring function to extract the relevant part of the string from the table's client name column value. First, write a select statement and call the substring function followed by a pair of parentheses. Then pass in the client name column as the first argument to the substring function. Pass in the start index as the second argument, which is the letter K, or character 1 of the string. And pass in the length of the string portion you need to extract as the third argument. The client's name is Kishan, which is 6 letters long. So 6 is our third argument. Then identify the table to target with the from keyword. Finally, add the where clause with the client's ID as the condition. Run the query to extract the client's first name. You've now helped M and G to complete their database tasks using string functions, and you should now be able to identify common MySQL string functions and explain how they're used to process and manipulate data. Great work. M and G are reviewing some recent orders delivered to the store. They must determine how many days have passed between the date these items were delivered and the day they were ordered. They can complete this task using date functions. In this video, you'll explore date functions and learn how to identify common MySQL date functions and explain how these functions are used to process and manipulate data in a MySQL database. First, let's find out what date functions are. Date functions are used in a MySQL database to extract time and date values in a range of different formats. M&G often use date functions to identify key time and date details for customer orders. Commonly used date functions that M&G take advantage of include current date, which returns the date in year, month, date format, and current time, which returns the time in hours, minutes, seconds format. There's also date format, which is used to format a date according to a given format, once that format is valid in MySQL. And date difference identifies the number of days between two date values. Perhaps M&G can use the date difference function to find out how many days have passed between orders. But before you find out how, let's take a few moments to explore the syntax for these functions. In most instances, date functions are written as select statements. To extract today's date in year, month, date format, just type select, the current date function, and open parentheses. For the current time in hours, minutes, seconds format, type select, the current time function, and open parentheses. However, the syntax becomes a bit more complicated with date format and date difference. To change the date format, type the date format function and open parentheses. Within the parentheses, type today's date in standard SQL year, month, date format, enclosed in double quotation marks. Then input a valid MySQL format in a pair of single quotes. You can refer to the further reading section at the end of this lesson for a list of valid formats. To determine the number of days between two date values, type the select command and date difference function followed by parentheses. Within the parentheses, type the first and second date values in year, month, date format and ensure both are enclosed in double quotation marks. Then run the query to create the output. Now that you've reviewed the syntax for date functions, let's see if you can use this knowledge to help M&G. M&G need to complete a series of time and date tasks using date functions. The first of these tasks is extract the current date and time. To retrieve this data, just write select command followed by the current date function, and a second select command followed by the current time function. Execute these queries to return the current date and time. Now M&G needs you to format a date by displaying the month name of a given date. You can do this by using select and calling the date format function. Then pass in the order date as the first argument. Type the required format to get the full month name. Finally, identify the required table. Execute the query to create the output. For the final task, M&G must determine the number of days between the delivery date and order date for their most recent orders. As you discovered earlier, the date difference function can be used to complete this task. The delivery data is contained in the MG orders table. The table records delivery data within the following columns: order ID, item ID, quantity, cost, order date, delivery date, and order status. To complete this task, you need to focus on the values from the delivery date and order date columns. First, write a select query and call the date difference function. Pass the values from the delivery date column as the first argument. Then pass the values from the order date column as the second argument. Use the from clause to target the MG orders table. And finally, use the where clause to filter out the records that do not have a null delivery date. Once executed, the query reveals the number of days between the delivery and order dates for the most recent orders. M&G now know how many days passed between the delivery date and order date for their most recent orders. And you should now be capable of using common MySQL date functions to process and manipulate data. Well done. M&G are approaching the end of their business year and need to extract sales revenue data for each item in their inventory. They can extract this data using comparison functions. Over the next few minutes, you'll explore the concept of comparison functions. And by the end of this video, you'll be able to identify common MySQL comparison functions and explain how these functions are used to process and manipulate data in a MySQL database. So, what do database engineers mean by the term comparison functions? MySQL comparison functions allow you to compare values within a database. For example, the function can be used to determine the highest, lowest, and other values. A benefit of comparison functions is that they can be used with a wide range of values, including numerical, strings, and characters. Here's a few examples of MySQL comparison functions. The greatest function is used to find the highest value. Least determines the lowest value. And isNull is used as an alternative to the equals operator to test if a value is null. To demonstrate the syntax, let's identify the highest and lowest values from a table that contains numerical values only. The syntax begins with a select command, followed by the name of the required column. Often this is the column that holds the table's primary key or identifying attribute. Next, type the greatest function, followed by parentheses containing the names of the columns you need to compare. Then use the as keyword with a column alias of highest to ensure SQL returns the required values in a new table under this column. Next, utilize the least function in the same manner. Finally, identify the table to be queried. For example, M&G can use the greatest and least syntax to extract sales revenue data. They can target the last 4 business quarters and deliver the highest and lowest values from each. You'll find out more about how M&G can do this in a few moments. For now, let's look at the syntax for the final comparison operator, isNull. isNull is often used with a select command, followed by the name of the required column. Then a from keyword is used to identify the required table. An isNull function can also be used with a where clause. The clause calls the isNull function and identifies the column it must pass through. Now that you're familiar with the syntax of comparison functions, let's take a few moments to find out how they're used in the M&G database. As you learned earlier, M&G require data on their sales revenue for each item in their inventory for the last 4 business quarters. The sales revenue data is contained in the sales revenue table. The table has 5 columns. One column called item ID, which identifies each item in the inventory, and an individual column for each quarter. M&G first need to identify the highest and lowest revenue each item brought in over the past 4 quarters. You can help them by using the greatest and least comparison functions, just like the syntax example from earlier. Start with a select command and list item ID as the first column. Then, to identify the items that brought in the highest revenue, call the greatest function and pass the 4 business quarter columns as arguments. Then create the alias highest. Write a similar line of syntax for the least function and assign it the alias of lowest. Finally, use the from keyword to target the sales revenue table. Once executed, the query's output presents the highest and lowest sales revenue values for each item over the last 4 business quarters. For example, the item with the ID of 1 was worth $138,000 to M&G at its peak, and $60,000 during its lowest sales period. M&G need to determine which of their most recent orders have yet to be delivered. The delivery data is held in the MG order table. The table contains 7 columns: order ID, item ID, quantity, cost, order date, delivery date, and order status. The delivery date column is your primary concern here. All orders yet to be delivered have a null value within this column. So you can use the isNull function on this column with the where clause to filter these orders. Begin by writing the select statement as usual, followed by an asterisk. Then use a from keyword to target the table. Finally, write a where clause and call the isNull function to pass through the delivery date column. Once executed, the query returns a value of 3. This is a true value for all records that have a null value for the delivery date column. M&G now have their required sales data, and you should now be able to use comparison functions in a MySQL database. Great work! M&G need to determine which items in their inventory are turning a profit and which items are making a loss. They can use a control flow function to carry out this task. Over the next few minutes, you'll explore control flow functions, and by the end of this video, you'll be able to identify common MySQL control flow functions and explain how these functions are used to process and manipulate data in a MySQL database. So, what are control flow functions in a MySQL database? Control flow functions let you evaluate conditions and determine the execution path or flow of a query. The most common control flow function used in a MySQL database is the case function. The case function runs through a set of conditions contained within a case block and returns a value when the first condition is met. Let's take a moment to explore how this function operates. The case function is held within a case block. It operates in a similar manner to an if-then-else statement. Once it finds a condition that's true, it returns the result. If no conditions are true, then it returns the value specified in the else clause. If there's no else clause and no conditions are true, it returns null. So, what does the full syntax of a case function statement look like? First, write a select keyword, followed by the name of one or more columns that contain the required values. This is followed by the case function, which denotes the start of the case block. Next is the list of conditions which are written using the when and then clauses. The case block is then closed with the use of an end clause. You can also add an alias for the expression, depending on the needs of your code. Finally, identify the table to be queried. For example, M&G can use the case function to identify which items in their inventory are loss-making and which ones have turned a profit. They can extract the sales data for each item from the sales revenue table. Any items with a value less than or equal to $25,000 are considered loss-making. Any items with a higher value are viewed as profitable. MySQL displays the terms profit or loss next to each item's ID depending on the result. Let's take a few minutes to explore M&G's database and find out how they extract sales revenue data using a control flow function. As you've just discovered, M&G need to check which items in their inventory have turned a profit this year. Any items that have accrued at least $25,000 in sales are considered profitable. All other items are making a loss and should be removed from sale. The data they need is contained in the sales revenue table. The table has 5 columns. One column called Item ID, which identifies each item in the inventory, and an individual column for each of the 4 business quarters. By checking if the value of the lowest quarter is less than or equal to 25,000, M&G can determine which items made a profit and which items made a loss. The easiest way to perform this task is by using the case control flow function. First, write the select statement and target the Item ID column. This is the column you need to display results against. So, write the case keyword to begin your case block. In the case block, write when and give the condition with the least function. Then list the quarterly sales columns in parentheses. The next set of steps involves the operator and conditions. Write a less than or equal to operator, and write then to specify what information you intend to display if the condition is true. In this instance, you need to display the word loss. Then write the else keyword and specify what information must be displayed if the condition is false. In this case, it's profit. End the case block with the end keyword. Now you need to create the aliases and identify the table to be targeted. Use an as keyword to create the profit-loss alias. This is the name of the column that the results of your case query are placed in. Finally, write the from keyword and target the sales revenue table. Execute the query to extract the results. The results show that items 1, 4, 5, and 6 generated a profit, while items 2 and 3 made a loss. M&G have now completed their database tasks with your help, and you should now be able to use control flow functions when writing SQL select statements. Nicely done. Lucky Shrub often perform the same queries on their database every day, and each time they perform these queries, they have to rewrite the same SQL code again. There must be an easier way, right? Well, with MySQL, Lucky Shrub can use the stored procedures method to save a specific query as a block of code that they can then recall whenever required. Over the next few minutes, you'll discover how this works by exploring the concept of stored procedures. And by the end of this video, you'll be able to demonstrate an understanding of stored procedures in a MySQL database, and create and drop simple stored procedures in MySQL. So, let's begin with an overview of what database engineers mean by the term stored procedures. A stored procedure is a block of code or pre-prepared query that can be stored in your database. You can then invoke or call the stored procedure using the call command. There are a lot of benefits to be gained from using stored procedures. With stored procedures, your code is more consistent. Your code is also reusable. You no longer need to write the same SQL statements repeatedly. And your code is also easier to use and maintain. Next, let's explore the syntax to get a better understanding of how the stored procedure works. First, to create a basic stored procedure, write the create procedure command. This must be followed by the name of the procedure and a pair of parentheses, which hold the list of parameters. This parenthesis is required even if your stored procedure contains no parameters. Then write the rest of your procedure logic as required. For example, if your procedure must select all data from a table, then write a select command with an asterisk and the from keyword followed by the table name. When writing a stored procedure with one or more parameters, the syntax is much the same. The key difference is that you must include all required parameters within the parentheses. Then write the rest of your procedure logic. Once you've created the stored procedure, the next step is to invoke it. To invoke a procedure, you can use the call command followed by the procedure name. Make sure to include the parentheses. But what if you no longer required a stored procedure? How do you remove it from your database? To delete a stored procedure, you can use the drop procedure command followed by the procedure name. In this instance, you don't need to include any parentheses. As you learned earlier, Lucky Shrub make heavy use of the same queries in their database. For example, they often need to query the list of products in their database products table to find items for customers or check what's in stock in their store. However, they need to rewrite the same query each time they interact with the products table. It's a time-consuming process. Why don't you use your new knowledge of stored procedures to help them create a reusable query? Lucky Shrub need to create a stored procedure that can extract all data from their products table. The table holds data on all products in the store and is divided into 3 columns. The product ID column, the item column used to list all products by name, and price column, which lists all prices rounded to 2 decimal places. To create a stored procedure that returns all data from the table, you can write the following syntax. Begin with the create procedure command, followed by the procedure name. Since the goal of this procedure is to return details of all products, you can call it get products details. Then add parentheses. This stored procedure doesn't require any parameters, so you can leave the parentheses empty. Next, write a select command and an asterisk symbol to instruct MySQL to extract all data. Finally, write the from keyword and target the products table. Click enter to run the query. The new procedure get products details has been created. Lucky Shrub can now call this query to extract data from the table instead of rewriting a new select statement each time. To demonstrate the stored procedure, just write the following call command. Call get products details and parentheses. Click enter to run the procedure and extract a set of results that includes all product data. Lucky Shrub also frequently write queries to identify the lowest priced products in their database so that they can add these items to sales or promotions. You can create a stored procedure with one or more parameters for this query. Begin with the create procedure command. Then write the procedure name. You can call it get lowest priced products. In parentheses, you need to declare the parameters, lowest price and the integer value. These parameters return the lowest integer values in the form of a table column called lowest price. Next, write a select command and an asterisk symbol. Then write the from clause and target the products table. After the from clause, include a less than or equal to operator, followed by the lowest price parameter. Click enter to execute the query. In this statement, you've declared a parameter with an integer data type that must pass an integer value into the stored procedure. However, don't forget that this query also includes parameters. So each time the query is called, you need to specify the value the stored procedure must process. As an example, let's return the data of products with a price of less than or equal to $50 by typing the call command, the get lowest price product stored procedure name, and placing the value of 50 in parentheses. Click Enter to execute the query. The query passes the value of 50 to the stored procedure through the parameter. The output appears on screen with a list of all products priced less than or equal to $50. Finally, Lucky Shrub have decided to remove the Get Products Details stored procedure from their database. To drop the stored procedure from the database, type drop procedure command and the name of the procedure, Get Products Details. Click Enter to execute the query. The stored procedure has now been dropped from the database. Lucky Shrub can now perform queries in their database much more efficiently thanks to the use of stored procedures. You should now be able to demonstrate an understanding of stored procedures in a MySQL database and create and drop simple stored procedures in MySQL. Well done. Congratulations, you've reached the end of the third module in this course. Let's take a moment to recap on some of the key skills you've gained in this module's lessons. In the first lesson, you learned about functions in MySQL and should now be able to explain the concept of MySQL functions, differentiate between common types of MySQL functions, and make use of basic MySQL functions in a MySQL database. And you demonstrated your knowledge and skills with MySQL functions in the labs and quizzes. The MySQL functions that you encountered included numeric functions, which are used to aggregate data or perform mathematical operations, string functions, deployed on string values in a database, and date functions, which return time and date information. You also explored comparison functions and discovered how they can be used to compare values in a database. And finally, you learned how control flow functions are used to evaluate conditions and determine the execute path of a query. In the second lesson, you explored stored procedures and should now be able to explain the concept of stored procedures in a MySQL database and create and drop simple stored procedures in MySQL. You also demonstrated your skills in a lab environment. Having completed this module, you should now be able to make use of functions and MySQL stored procedures. Great work. In this course, you learned about database structures and management with MySQL. Let's take a few moments to recap the key topics that you learned about. In the opening lesson, you received an introduction to MySQL. During this introduction, you learned about databases, discovered how Meta makes use of MySQL databases on a day-to-day basis, and you learned how to make the most of the content in this course to ensure that you succeed in your goals. You then moved on to the next lesson, in which you learned how to filter data. In this lesson, you learned how to filter data using the AND, or, not, in, between, and like logical operators. Combine conditions with the use of logical operators. You learned how to identify wildcard characters and explain how they're used to filter data. And you then demonstrated your knowledge of data filtering in a series of knowledge checks. In the next lesson, you explored the concepts of aliases and table joins. You can now explain the concept of an alias and demonstrate how they're used in a lab environment. Outline what a table join is and explain different types such as inner, left, right, and self joins. Demonstrate how to join tables and make use of the union operator in a MySQL database, having completed the video and demonstrated your skills in a knowledge check. You then learned about grouping data. Use the MySQL group by clause to group rows and deploy it with aggregate functions. Demonstrate the use of the MySQL having clause to apply filter conditions. Make use of the any and all operators. And you demonstrated your ability to group data in a lab environment. Next, you began the second module, in which you explored different techniques for updating databases and working with views. In the first lesson of this module, you learned how to insert and update data. You can now update and insert data using the replace command. Identify the main types of constraints like key, domain, and referential, and explain how they function. Add, delete, and modify columns with the use of the alter table command and make use of subqueries. You then learned about views in MySQL databases. You can now explain the concept of views, create, rename, and drop views in a MySQL database, identify the advantages of using views, and you demonstrated your knowledge and skills with views in a series of knowledge checks and ungraded labs. In the third module, you were introduced to functions and MySQL stored procedures. You can now explain what a function is and identify different types of functions. You can use numeric functions to aggregate data or perform mathematical operations. You can manipulate string values using string functions, extract data on time and date values with the use of date functions, compare values using comparison functions, and you can deploy control flow functions to evaluate conditions and determine their execution path. In the final lesson of this module, you explored the concept of stored procedures. You can now explain what stored procedures are in a MySQL database and create and drop simple stored procedures in MySQL. You've reached the end of this course recap. It's now time to try out what you've learned in the graded assessment. Good luck. You've reached the end of this Meta Database Engineering course. You've worked hard to get here and developed a lot of new skills along the way. You're making great progress on your database journey, and you should now understand database structures and management with MySQL. You were able to demonstrate some of this learning along with your practical database skill set in the lab project. Following your completion of this course in Meta Database Engineering, you should now be able to filter, join, and group data, insert and update data in a database using constraints, subqueries, and views, and deploy functions and stored procedures in a MySQL database. The key skills measured in the graded assessment revealed your ability to demonstrate your knowledge of key MySQL topics like filtering, joins, and data grouping, explain database concepts related to virtual tables, data integrity, and subqueries, and exhibit your experience with functions and stored procedures. So, what are the next steps? This Meta Database Engineering course has given you an initial introduction to several key areas. You probably realize that there's still more for you to learn. So, if you found this course helpful and want to discover more, then why not register for the next course? You'll continue to develop your skill set during each of the Meta Database Engineering courses. In the final lab, you'll apply everything you've learned to create your own fully functional database system. Whether you're just starting out as a technical professional, a student, or a business user, the course end projects prove your knowledge of the value and capabilities of database systems. The lab consolidates your abilities with the practical application of your skills. And the lab also has another important benefit. It means that you'll have a fully operational database that you can reference within your portfolio. This serves to demonstrate your skills to potential employers. And not only does it show employers that you are self-driven and innovative, but it also speaks volumes about you as an individual, as well as your newly obtained knowledge. And once you've completed all the courses, you'll receive certification in Meta Database Engineering. The certification can also be used as a progression to other Meta role-based certifications. Depending on your goals, you may choose to go deep with advanced role-based certifications or take other fundamental courses once you earn this certification. Meta certifications provide globally recognized and industry-endorsed evidence of your technical skills. Thank you. It's been a pleasure to embark on this journey of discovery with you. Best of luck in the future.